one of the key skills that you need to have is to able to verify whether certain function given is indeed a solution to this differential equation. So there's a lot of instances like that. So in this case, it's pretty straightforward. All we need to do, the strategy is of course to differentiate this. Okay, you task to differentiate this, and then check that you substitute the differentiations into the equation, and if it satisfies, then yes, then that would have already verified. So what we do is we start with the function given. Now do not try to integrate. Now some students will try to integrate this one, just digress a bit, this thing. No, don't do that. Since the solution is given to you, just differentiate this. Differentiation gives you this one, and notice that this part here, allow me to do this, is really is y. So therefore you can then see why this is actually equal to k times y. Yeah, just in case I just point out to you, this part is actually y, you see here. So that's why it's k times y, and so it's verified. So this is. Now look at another examples to talk about obtaining differential equation, and also like the idea of differential equations also. So different equations, but you can see that the problem itself is slightly more complicated, because here is actually a second order, so you derive this 2 times. In other words, you have this supposed to show that this is a solution. You perform the same process, you differentiate this once and twice, and then you substitute this back into here and see what happens then. Okay, so you would have y equals to 1 over 2t minus 1 power 2. An easier way to do this is actually, I'm going to write this in form of not in a rational, so it's negative power negative 2. If I differentiate right now, I'm going to differentiate this 2 times, and this would you should get these 2 something like that. Yeah, here, and you differentiate this 1 more time, and here we have this. Notice carefully that this is actually what you're supposed to show. Let me write them side by side, and you should be able to know what to do then if you try to compare them. And note carefully that here's a 24, just nice, so you don't have to do anything, so leave that. Y prime is y double prime, y double prime. Yes, we have y squared, but your differentiations is leaving you with this 2t minus 1 to the power of negative 4. We go back a bit and look at this. This is 2t minus 1 to the power of negative 2. So do you see a connection? This is the power of negative 2, power of negative 4, and here's supposed to see y squared. So we try to work it out, so we get to make this to look something like the one in y squared, something like that. So here we go. So here we have this situation now. Okay, we copy this, and I supposed to see 2 here square, and if you think about this, the only option I have now, put it in brace, would be to have the power, the exponent, as negative 2, because by rule of indices this is equivalent to negative 4, which is the same as the original expression here. So finally we'll have 24, but then this is y. Recall that this is actually really is y, okay, right here. So that means this is y squared, and again this is shown. This is really successfully shown that this function is really a solution of these differential equations.